Hey guys, so jumping into Unit 2, Lesson 1, Exponent Rules. I'm starting our unit on polynomials. We're going to look at how to simplify an exponential, and I should have said expression. With the ultimate goal, eventually being able to solve an equation. That's our goal. So if we can simplify first, then eventually we can get into how to solve those. And so being able to perform operations using exponent rules and utilizing scientific notation makes this process go a lot faster. And it leads into lessons later on because we're going to use the same rules as a foundation for like our logarithms and our exponential equations. So these rules will come back and we'll utilize them several times. Okay, so just keep in mind that you have a base value when you're dealing with exponential expressions. And so like if a to the n is your exponential expression, the base here is a and the exponent is n. And so we talk about like what to do with the exponents. We talk about what that base value needs to be. And so make sure you understand when I say base, what I am actually talking about, referring to. Okay. So just reviewing the rules here. If you have a negative exponent, then that is going to invert your exponential expression, right? The only sign that will ever change when you do this is the sign on the exponent. So it doesn't matter if you move it bottom to top or top to bottom, it will change signs, okay? So this works both ways, and it will change signs. So same thing would happen if we move it from the top to the bottom, it would become negative, okay? So you think about why this works. And if you have 1 over a to the negative n, that's the same as 1 over a to the positive n, and if we invert it, right? Well, if you utilize your algebra rules, then we're going to just take that top times the reciprocal of the bottom, which is then just a to the n. So that is why this rule is true. Okay. Another exponent you need to watch out for is a to the 0. Because 0 can do some strange things. When we multiply by the number 0, we just get 0. But the rule for this, a to the 0, anything to the 0 power is equal to 1. So please be careful. Because it's anything at all that's raised to that power. So if you have, for example, AB, both raised to the 0 power, it's grouped together, then that is 1. But let's say you have a, b to the 0, then this 0 is just on the b, and that's equal to a. All right, so the 0 here is just on the b. So keep that in mind. All right, and that only works if a is non-zero. 0 to the 0 power doesn't do the same thing. You're not going to make it 1. It's still just 0. All right, and then we have your product rule. So hopefully, again, you saw that pattern in the warm-up. Product rule is just knowing that if you have the same base, so a times a, then you're going to take those exponents and add them together. All right. If you have your power rule, so we have a to the m raised to the n, Then we're going to multiply those together. So look at the difference visually here. And see the difference. So here we have two bases, right? We're multiplying those bases together, so we're going to add the exponents. Right here we have one base, and so we're going to take that and multiply them together. So see the difference here, because that will be key for simplifying problems. Your quotient rule, when you divide things with like bases, again, we have two different bases, then you can subtract. And it doesn't matter which way you subtract. So generally, I will take the smaller number to wherever the bigger number is located, so I don't end up with negative exponents. But then you would just put a 1 on the top, whatever, if there's other things left on top. Okay? And so just keep all of that in mind. Your product power, remember that if there is no addition or subtraction, that you can distribute into parentheses. So all of this should be raised to this power. So we have a to the n and b to the n. Right, this just goes through because this is multiply. Quotient rule works the same thing. A lot of the times multiplication and division will follow those same rules. So this just distributes to everything. So a to the n over b to the n. All right, you have to take it to the top and the bottom. All right, so looking at what changing the signs on both the base and the exponent, how that affects your number. All right, so we're going to just evaluate these expressions. So we have 3 to the second. That is just 9. Right? Negative 3 to the second. This one is different because we're just going to raise that power. So we get 9, and then that negative is going to tack back on there. Right? That negative is not being squared. Then we have 3 to the negative 2. We talked about how to make that exponent positive. So this is the same as 1 over 3 squared. So then that would be 1 over 9. All right, these are going to act similarly. We're going to take that and flip it. Notice that this negative stays put while this negative becomes positive. So only the sign on the exponent will change. All right, now because this negative is outside, we're just going to take that 3 squared. The negative doesn't get squared. And so we end up with 1 over negative 9, or negative 1/9. And I always move my negative from the bottom either to the top or into the front. It doesn't matter. But take it out of the bottom of your fraction, please. And I think I made that go into pages here. All right, so this one is different. So this one and this one do not mean the same thing. So make sure you pay attention to those differences there. This means negative 3 times negative 3, all right, which is positive 9. Okay. Same thing here. We're doing 1 over negative 3 squared. All right, so only the sign on the exponent changes. So we get 1 over positive 9 because we're squaring the negative as well. Okay, so pay really close attention to your signs as you do those problems. All right, so then you follow those rules and simplify this. So for this one, maybe I flip it first. So to make this a positive, I'm going to take 4/3 and raise it to the positive 3. I'm going to distribute that to both the top and the bottom so that I have 4 to the 3 over 3 to the 3. And then I'm just going to do that in my calculator and get 64 over 9. All right. trying that one more time, I'm going to flip this fraction over. So I have negative 4 over 3 raised to the second. Right? I'm going to take that 2 and I'm going to distribute it through to both of these. And because this negative is inside of these parentheses, I'm going to keep it inside of my parentheses and put the 2 on the outside. And then I'm going to put 3 squared on the bottom. Now that negative doesn't matter which one you put it on, but I still want it in parentheses because it started in parentheses. And so if I square that, I get positive 16, and if I square that, I get 9. So next we're going to move into simplifying things. And so when you're simplifying, it's good to just kind of generally follow a certain flow so you don't break any rules. And now it doesn't particularly really matter, but when we get into the longer and bigger simplification problems, a lot of people accidentally miss a step or break a rule. So here's kind of the order that I go in. So your 0 rule, apply that first, because anything to the 0 power is 1. You can usually, in a large expression, just get rid of them because you're multiplying by 1. So it's just absorbed into the problem. Then I do my power rules. So this one is kind of specific. You will need to get rid of your parentheses first if you can. So sometimes that means flipping things to make an exponent positive. So sometimes these can be used interchangeably, these two rules here, depending on where that exponent is located. But sometimes it just means distributing an exponent through. Then do any negative rules, so you can go ahead and flip those. This one is a bit iffy. I don't usually actually do that until the very, very end, unless I'm flipping a fraction to make the outside number positive. So again, these are pretty fluid. Look for your product rule and your quotient rule. Like, can you combine like terms on the top, and then can you combine things top to bottom? And that is usually the last thing that you can do to simplify, okay? If you have number coefficients, you can raise those to a power and go ahead and simplify those. Otherwise, you should be fairly done. So yes, like these could be done in a calculator, but we're getting into problems like this where you can't do it in a calculator, so you really need to know the rules. Okay? So even though you can get things done in a calculator if they're numerical, you need to know the rules for this. So as we simplify each expression, I'm going to kind of follow those steps that I just outlined. So first, I'm going to kind of get rid of these parentheses. So to do that, I need to distribute this through. So I have negative 2 to the third, x to the third, y to the third. This one doesn't have anything, so I'm just going to put times 4xy to the negative third. All right. I'm going to go ahead and raise my 2 to a power so that I can simplify this. So I get negative, well, actually I'm going to do two things at once here. I have my like terms here, here, and here. So I'm just going to combine my like terms all at once. So 2 to the third power times 4, and it's negative 2 to the third power times 4. So if you do that in your calculator, you'll get negative 32. 2 to the third is 8. That makes it negative. Times 4 is 32. All right, so you could group that together if it helps you see it. You're doing negative 2 to the third times 4. That's one group. Then we have x cubed times x. That's our next group. And then we have y to the third times y to the negative third. And this is why I don't apply my negative rule yet. So again, that's negative 32. My product rule tells me to add these. So remember, if there's no number there, it's a 1. So this gives me x to the fourth. And then your y's here, same thing. We're going to add those, but 3 and negative 3 goes to 0. Which just equals 1. And so we don't need that in our final answer. So this is your simplified form. All right, so again, just following down those rules. So I have no zeros to get rid of. First thing I'm going to do is my power to power, and I'm going to distribute these through. So I have -2 to the -1. That's not +2. We're not multiplying those. Then I have a to the 1 and b to the -2. Then I have a to the 6th. Remember, we multiply those. And then I have a to the -15. Now, if it makes more sense to you for you to move your negative exponents down, then that is fine. I tend to go left to right and simplify by combining like terms first. So, for example, I have -2 to the -1. I'm just going to leave that alone for now. And then I have a to the 1st, a to the 6th, a to the -15, and then I have b to the -2. All right, so I just kind of look at my like terms first, and you don't have to group them like this if you can kind of just see it visually yourself. So this is going to flip to -1/2. All right, that becomes a +1. The sign in front does not change. This, we're going to add all of these, and so we get a to the negative, that's 7, so 7 plus -15 is -8. And then I have a b to the -2. Well, my final answer, I need positive exponents in it. So I'm going to get -1/2 times 1 over a to the 8th times 1 over b to the 2nd, flipping both of these to the bottom so their exponents become positive. And when you multiply fractions, you just go straight across. So I get -1 over 2a to the 8th, b to the 2nd. And that will be my final simplified version of that problem. These book numbers aren't for you guys. All right, so I'm just going to kind of continue on here. If you would go ahead and I'm going to stop the video. Try this one on your own, just like on a scratch paper off to the side, and then click continue. Okay, hopefully you got x squared over 24. Actually, okay, so hopefully you got x squared y to the 5th over 24. Be careful, I even made a mistake and had to go back. I forgot to put my y to the 6th in here, so that was y to the 7th. But you can pause the video if you need to and kind of look at my steps if you can make sense of my madness. I just split up my like terms top to bottom after I combine like terms across and then simplified from there each one. Okay. This next one I'm also going to have you pause and try on your own, but I'm going to help you get started here. This is over 1, so this problem can actually be rewritten, and I'm just going to go ahead and distribute as I go. And actually, no, I will distribute as I go, so that I have 3 to the -2, x to the 2, y to the -6 times 9x to the -9, y to the 5th, all over. So this can just move up to the top because it's over 1. All over 3 to the 3rd, x to the 3rd, y to the -3rd. All right. Now, if you look at this problem carefully, and I know I said I was going to make you pause it, but if you look at this carefully, hopefully you can recognize the fact that this 9 can be written with the same base as the numbers that you already have, and that will save you a little bit of time on this problem. Okay, so I can combine like terms because this is 3 squared. All right, so when I rewrite this problem, I can bring up my like term here if I want, and I can combine my x's and I can combine my y's. And you can do that all at once, all right? So I have this, I'm going to bring up so that all of my x's are just all on one level, and that's fine. It'll be negative. I'm going to minus 3. So this is going to rewrite as 3 to the negative 5th, all right? My x values, I have a positive 2, I have on the bottom a 3, and at the top of here I have a negative 9. So 2 plus negative 9 is negative 7, minus 3 more is negative 10. All right, so 2 minus 3 is negative 1, plus negative 9 is also negative 10. Okay, so keep in mind this is going to switch to a negative when it flips up to the top. Y's, I'm going to do the same thing. I have a negative 6 up top, a negative 3 on the bottom, and a 5 up here. All right, remember you add across the top, but then you subtract the bottom. So this would be negative 1 minus negative 3. This is going to become a positive 3 when you move it up. Gives you a y squared. All right, if you need to expand it like you did up here, then do that. Okay, I'm making a lot of shortcuts on this particular problem. Okay, this one I still have, so times, I haven't combined that yet, but I'm going to change it to 3 squared, and this is your 9. Okay, so this 9 right here is going to come down as 3 squared. And so my last step, I'm going to combine these here. So this gives me 3 to the negative 3, x to the negative 10, y squared. And then I'm going to move so that I don't have any negative exponents. So I have y squared on top because it's positive. 3 cubed becomes 27 on the bottom, x to the positive 10. All right, so 3 cubed is 27, but because of the negative exponent, it needs to move down. All right, and that's your final simplified version of that problem. It's already too long. All right, quick review of scientific notation. Remember that a positive exponent means that you're expanding the number, and so 8.82 times 10 to the 5th means that it's moving 5 places that way. And so we have 882, so we've moved it twice, 3, 4, 5 places that way would be the expanded version of that. All right, a negative exponent is going to simplify, is going to show us how many decimals we're moving it that way. So 0, sorry, we need one number less than 10 in front of the decimal, so 7.58 times 10 to the, and then however many times you moved that. So 1, 2, 3, 4 times, and it's negative 4. All right, so this would be your constricted version of that. So remember, scientific notation is a product of a number between 1 and 10 and a power of 10. And by power of 10, I just mean 10 to the whatever. All right, so you have a times 10 to the nth, where 1 is less than or equal to a, which is less than or equal to 10, or just less than, excuse me, which is less than 10. And n is an integer. That's an E. All right, all this is saying all you really need to know is that you have a number times 10 to a power, and that number needs to be less than 10. All right, so 7.58. To do calculations with them, because we have those like bases, that's how we're going to look at this. So we're going to use our rules of exponents. So we have 6 times 10 to the third times 5 times 10 to the negative fifth, right? So we have our constants, but then we also have our base 10s. And so since those base 10s match, we can split this up so that they are together. And then we can just follow our exponent rules. So like bases, we add our exponents. So we have 30 times 10 to the negative second. All right. Make sure that your final solution is in scientific notation. So I'm going to move 1 to the left, which means I'm actually going to add 1 because I made the number smaller, and when I go back, I want to make it bigger. So this is 3 times 10 to the negative 1 would be my final answer in scientific notation. All right, division is the exact same, only you're dividing instead of multiplying. So 2.6 times 10 to the negative 6 over 5.2 times 10 to the negative 4th. We're going to kind of just split this up. We have our numbers. We have our base 10s. And then you can just type that in a calculator. So 2.6 divided by 5.2 gives you 0.5. This would give you 10 to the negative 2, right? We're moving this up. We're always just going to move these up. So negative 6 minus negative 4 gives you negative 2. This is once again not in scientific notation. I need to move this once to the right. I moved it right. So I'm going to subtract 1 from this exponent. And so my final answer will be 5 times 10 to the negative third. All right. So that's it for scientific notation. We'll use that with some of our conversions and stuff later on. So it's good just to review it.